Good evening and welcome to the RENA and IMRS Southern Joint Branch lecture on large yacht stability, getting it right. Before I introduce you to our speaker tonight, I'd just like to run through a little bit of housekeeping. So for those of you who have not attended one of our lectures before, we leave all the questions to the end, and you can ask the questions in one of two ways. You can either type your question into the Q&A, and there is a difference between the Q&A and the chat, so it would be preferable if you use the Q&A option. And alternatively, if you would like to actually ask your question verbally, you can raise your hand and then we can, we'll see that and we can unmute you and then you can ask your question. The only thing to remember there is we are recording this lecture. So if you don't want to be in the recording, it might be best to just type your question into the Q&A box. As I said, we are recording the lecture and it will be available on YouTube in the next few days. So without further ado, our speaker tonight is Andy King. Andy graduated from Newcastle University with, I believe, a first-class degree in naval architecture in 2007. He then went to work for Kinetic and then after that, Global Maritime. Andy joined Lloyd's Register 10 years ago now and went to work for the Stability, Load Line and Tonnage team, where he's been ever since and is now the team lead of the Stability, Load Line and Tonnage team. Andy has a wealth of experience in the topic of large yacht stability, and I'm sure this is going to be a very interesting lecture. So Andy, if I can invite you to share your screen.
Yeah. Right. Can you see that, Lizzie, and can you hear me?
I can see it and I can hear you.
Good. Okay, I will make a start, and if that's okay.
That's fine, thank you.
Lizzie. And firstly, good evening, everyone, and welcome to my presentation entitled Large Yacht Stability and Getting It Right. My name is Andy King. I work for Lloyd's, as Lizzie said, have done for nearly 10 years. I am based down here in Southampton, and I'm a lead naval architect looking after a team of naval architects who are doing stability, load line and tonnage plan approval work. We deal with a huge variety of ship types, but primarily a lot of our work is focused on large yachts. So the content of our presentation this evening is to focus on large yachts and their stability aspects. We'll talk about large yachts and what they are. We'll talk about the applicable codes, the applicable class rules, the flag delegation and how we work with them and how we conduct our stability approvals. We'll talk about stability booklets, what they are and what they should contain. We'll then look at intact and damaged stability compliance and how we demonstrate it and then approve it. We'll then talk about incline experiments, lightweight surveys and the importance of getting them right. And then we'll look at the common questions and hot topics, the things we get asked all the time at Lloyd's that might then be common across the industry. We'll then have some chance at the end for questions. So firstly, large yachts, how do we define them and what do they have to comply with? Well, large yachts are any yacht over 24 meters in load line length. They are typically commercially registered, but can also be privately registered as well. By commercially registered, we mean they're available for charter and using by other parties, fee-paying parties. They are commercial by nature and used for sport or pleasure, and they do not carry cargo. And they are explicitly limited to carrying no more than 12 passengers. They can be motor yachts or sailing yachts, and they can also be monohulls or multi-hulls. The focus of this presentation this evening is very much on motor monohulls, although if you have any questions on the other aspects, please obviously let me know at the end. We are also explicitly not covering passenger yachts, and by that I mean yachts of 13 to 36 passengers. And for that, I would kindly point you to the Part B of the Reg Code, which will become clear in a moment, which was previously the 6th edition of the Passenger Yacht Code. So what stability criteria do these types of vessels need to comply with? Well, originally, there was what was called LY1. That came about in 1997. That was then superseded by LY2 and then LY3, and is now the Red Ensign Group Yacht Code, Part A. That's the bit for large yachts up to 12 passengers. This is very much written and driven by the Red Ensign Group of flag administrations. And it's worth pointing out that there are other flag administrations that have their own yacht codes, own titled yacht codes, I should say, but the content is broadly the same. And by others, I mean Bahamas, Cook Islands, Transport Malta, and the Marshall Islands, to name a few. The code on stability is very high level. There is some guidance, but there are also some implementation methods that are missing. So Lloyd's and others got together and wrote some guidance and some interpretations, and that's largely what I'm speaking to you about this evening. There were critically no stability differences between LY2 and LY3, but there were some differences that came in recently in the latest Reg Code Part A. So this evening, we're largely referring to the latest version, and where anything is not written in a yacht code, we as Lloyd's generally refer to the next best place, which is the 2008 IS code. Now, as a summary of which code would apply to which vessel, because some of these large yachts can be a few years old, LY1 was from 1997, new vessel keel laying date. LY2 was a year later. LY3 was a keel laying date of October 13, but also slightly by the Maritime Labour Convention a couple of months earlier. And then the latest Reg Code Part A was January 19. So that's where we are now. And you can see in the middle column that these are all, each one was 24 meters of load line length. Before 1968 vessels had a tonnage limit, and there was also a tonnage limit in LY2 that was subsequently removed. But it gives you a nice summary of the 4 yacht codes and their keel laying date history. So that is the flag requirements. There is also then a class requirement to have approved stability information. Now, Lloyd's does not set out any stability criteria now in our rules. It's all driven by flag rules. But for large yachts, their general rule requirements are wrapped up in what we call the SSC rules, the Special Service Craft rules. Now, historically, before 2008, there were some stability requirements, and it either pointed you to A749, the old intact code, or flag requirements. But since 2008, the 749 has been taken out, and we now just purely point you to the flag requirements. It's worth saying that, again, historically, there were some additional criteria, such as wind and rolling criteria, the crowding of guests, and high-speed turning, but that's now all gone. And the damage stability criteria was historically much more complicated, with differing damage application lengths, differing damage extents. But the main point to take away is that everything is now much more consistent and tidier. LR rules are basically saying you must have approved stability information, and it points you to the flag for the requirements. So we as class are working with the flag. And how do we do that? And how do we then follow that through for stability approval for a large yacht? Well, it is absolutely important to say that LR, as a recognised organisation, are only able to undertake statutory plan approval work only when delegated to do so by the flag. The delegation comes from the flag themselves, and it can be a blanket delegation based on ship type or just the entire of Lloyd's, for example, or it could be a case-by-case basis as agreed with the flag. Now, LR cannot grant exemptions or equivalencies by themselves. The equivalencies and exemptions must be agreed in writing by the flag. They own the responsibility to do that. LR can be involved in discussing, recommending, supporting, providing evidence, etc., to support exemptions, or indeed give advice based on past experience, but we cannot be the ones that are agreeing exemptions take place. And on that, I should say in bold that any view or guidance or experience I mentioned this evening is always subject to future flag agreement. So if a new flag comes along or a industry changes opinion, that is worth bearing in mind. So given that we are delegated to do a particular job, and for a general new build yacht, how do we go about approving this stability? Well, for 99% of cases, the builder, the yard, the consultant, whoever we're dealing with, will submit to us a preliminary stability booklet. And that will come to us with a lot of supporting information, with which we will then seek to build an independent 3D computer model so that we can do our own calculations. We can then do our own independent intact and damage stability assessment to ensure compliance. We will then produce a set of comments, and we will wrap up those comments in what we call a design appraisal document or a plan comment form that is then our vehicle for transmitting those comments back to the client or the yard, whoever that may be. That may happen, and we may not hear anything for a year as the vessel then gets built, because stability typically and hopefully gets analysed quite early on. We may then not hear anything until the incline experiment takes place. So that is when the vessel is inclined, the weight check, centre of gravity check, and with that, with the result of that, which is accepted by Lloyd's, with the comments that are then hopefully actioned, the builder will then produce a final stability booklet, which will then be approved by us, all things being well, and that will then be physically placed on board for the master, which will become the overarching document on board for them to operate the vessel. To do this work, we typically request a very standard set of information. So it's worth going through what those key documents are. We will always request a GA, a capacity plan, a watertight integrity plan if it exists, the lines plan, although typically we get all whole geometry from a 3D CAD file. Now, ideally, we'd like that to be an IGES file, but we also accept other file formats on a case-by-case agreement. And then also any complex geometry, any complex surfaces, internal or external, it's always good to receive that in 3D. And obviously that information is very sensitive, commercially sensitive. So obviously we deal with that as required and keep it confidentially within Lloyd's. Then we also then ask for the stability booklet, obviously a preliminary and then eventually a final one. We also will ask for a damage calculation booklet. Now this may not necessarily exist. It could be an annex to the stability booklet as a set of calculations, but generally a set of calculations to demonstrate damage compliance. We will then have confirmation of the assigned draft for the vessel from both load line and scantling aspects, as well as eventually the incline report, the witness statement from the surveyor who attended the incline, and then if we need it, the flag delegation, if it's not been agreed previously on a case-by-case basis, we need a letter, and LR can arrange this on a client's behalf if it's easier. The above list is not exhaustive, and more may be needed if there's a bespoke part of a vessel that needs more analysis or needs more clarity from a drawing. So large yacht stability information booklets and how we demonstrate compliance. Stability information booklets are the overall and approved document that is placed on board after all of the work that we talked about in that procedure. I use the term stability information booklet carefully, noting that they are no such thing as an intact stability booklet and a damaged stability booklet. The stability information booklet is a catch-all document that covers all the applicable stability criteria under a single reference document. If there is a damage calculation booklet, it's a supporting document only, and it is the stability booklet which is formally approved and stamped. The form and content of the booklet can easily be based for a large yacht on a model booklet, which is freely available online, or we can provide a copy. And then the other content may be based on the guidance, which is well set out in the 2008 IS code. Broadly, the contents of such a booklet should include general particulars and the reference information, so things like datums and conventions, service and operating restrictions and how any tank should be used, the guidance on the use of watertight doors, the loading condition, a worked example with a blank form for the use, a limiting curve, and we'll talk about those shortly, and the guidance for use, the hydrostatic data, the cross curve data, which critically should cover the full draft and trim range of the vessel, and then also loading conditions, they're set out with the results and hydrostatics, including the longitudinal strength, if that's applicable. And then also at the back of the document, should be the accepted incline result or any lightweight survey reports that are also applicable. In terms of demonstrating intact stability compliance, this is done through the loading conditions in the booklet, which will set out the criteria pass or fail. But the overall aim for a yacht is to be inherently safe by design. So that's without or with minimal complex procedures or tank filling requirements. The loading conditions should include the last known and accepted lightweight parameters, all the tanks set out for use with their filling levels, percentages, centroids, and free surface moments, any applicable deadweight items, the pools and jacuzzis. And there is noting that there is very little difference between the floating position for a departure and arrival condition for a large yacht, just purely because the deadweight can be so minimal in terms of changing. But it is noted that the arrival condition can easily be a driving case for stability due to the higher VCG. Quite conventionally, the stability criteria is based on righting lever curves, and then the righting lever curve is terminated by any unprotected down flooding points. You can, with large yachts, get typical double hump righting lever curves where you have a superstructure tier that gives a classic shape to the curve and can give a second maximum, but it should always be driven, the termination of the stability, by the down flooding points, not by having a maximum later on in the curve. With damage stability, it's slightly more complex, but for large yacht codes, we are talking about what's called a pinhole damage method. Now, by that, I mean literally damaging one single compartment or one single tank as though you are poking it with a pin. The damage stability criteria that's set out in the codes is then based purely on the equilibrium floating position. Intermediate stages of flooding are recommended and can be analysed, as well as two-stage flooding scenarios if you have a situation where there's any divisions, such as cold stores or freezer bulkheads, which may collapse, but would give a two-stage flooding situation as it restricts the flow of water. Then damages should also account for any open connections. So for yachts, things like open big staircases on the main deck. We can also then accept non-standard permeabilities for spaces for large yachts if it gives a benefit and if it can be demonstrated by calculation and verified by a surveyor. So for example, you can accept a lower permeability for a given space to then reduce the floodwater in that space if it can be demonstrated as correct. We should also then be thinking about things like progressive flooding, cross flooding, internal down flooding. And in all these situations, particularly cross and internal down flooding, wherever possible, it should be self-acting. If it does need manual intervention, then it should be accessible above the bulkhead deck. The damage stability for large yachts gets more complicated as you flip over the 85-metre length. That's when you move away from just pinhole damages and move into SOLAS 90, the classic one compartment damage standard. And that is where the extent of damage is defined as per SOLAS 90. So you get more onerous and asymmetric damages, but the deterministic compliance is still as per the large yacht criteria. Then lastly, just one more point is on damage control plans. They are not explicitly set out in the large yacht codes, but there are some flags that have issued circulars that require them. So if you're working on a project, it is worth checking that out with the flag you are working with. The loading conditions that need to be checked for intact and damage stability are these ones. The top three are the mandatory conditions. The second batch of three are non-mandatory or optional. The load line condition, the first one, is the condition of the vessel loaded to the maximum assigned draft. If it is at 0 trim, then that's fine. If the vessel has a trim, then we seek for that assigned draft to be at the LCF position, such that the vessel is not having a benefit from being able to carry more dead weight if she has a trim, and then the maximum draft is being measured at the midship position. So that's worth bearing in mind. the departure condition may not be at the maximum assigned draft, but it's the vessel fully loaded with full stores and consumables, 98%, and with full crew and guests. The arrival condition is then the sister to that condition, so the departure condition, but with 10% stores and consumables. Then secondly, the lightweight, there may be a lightweight condition. It's non-mandatory, it's non-seagoing, and there is also non-seagoing overload conditions. So this is where the vessel may have tanks which exceed the deadweight capacity. And this is where we are having a condition which is demonstrating that the vessel is too deep if all the tanks are full. And then secondly, to help demonstrate a compliance between departure and arrival, there may be 30%, 50%, some other intermediate condition that shows how to get there, as well as optional owner conditions. With loading conditions, the aim is always to go from departure to arrival in a compliant manner. They are statutory conditions, so quite often we hear, oh, there's no point doing a 10% condition because the vessel will never get to that point. But the point is, the vessel may be able to get to that point. So we're looking at extremes, the statutory requirements. We should be looking to avoid consumable transfers, filling from fresh water makers. We don't accept stability compliance being achieved by active systems. It should be inherent by design. We should be avoiding filling tanks which are freshwater water ballast tanks by any other name. And then obviously heel and trim should be considered. Quite often we see forward trim, which can be an issue for yachts. And then with free surface moments, we should be following the guidance in the IS code and doing it in a logical and sequential manner. With limit curves, they are not explicitly required in the large yacht code, but Lloyd's and flags generally prefer to see them included. And the model stability booklet includes a template for doing them. Without it, there is no way of establishing damage stability compliance. With a bit of hard manual work, you can do intact by hand, but damage is nigh on impossible. But if you do have limit curves, they should cover intact and damage, everything for the vessel. They should cover the operational draft and trim range, and the loading conditions should also be plotted. There should also be working examples. And one thing we always seek to avoid is, and we often see, is avoiding multiple pages or multiple damage case curves replicated. Try and collapse them down, as you see in the example, onto one page. So the master has one source of information he has to refer to for stability compliance. Talking about the importance now of incline experiments and lightweight surveys for yachts. The lightweight parameters for any new build code compliant yacht must be determined by an incline experiment. We do not generally as class need to see a procedure, but only if we are looking at unusual arrangements for the incline or using water ballast. But generally in the industry and with class and flag, there is a concern over lightship and loading conditions, leaving no margin for future growth. So this is also something to bear in mind if you're involved in any projects. The incline should be as close to completion as possible, because if you do it too early at the end of build, you may then have some unknowns built into the final lightweight, and it may then cause problems when you come to your first 5-year lightweight survey. And then two common points to remember at the end for both inclines and lightweight surveys: they must always be attended by a class or flag surveyor for them to be valid and accepted. And the report for the incline must come to class, to our department, for acceptance, calculation checks, and then final agreement of the lightweight. With lightweight surveys, obviously, for those who are unknown, it's like an incline, but you don't get the VCG calculation. They are subjected for yachts every 5 years. And the vessel will then have to be inclined if any of those tolerances are exceeded. Noting that the VCG is pretty onerous, 0.25%, and you don't get a VCG from a lightweight survey. So that one only applies if we are doing modifications which are set out in a spreadsheet if there are known weight changes. So given the fact of having a lightweight survey, some seek to avoid it by the clause in the large yacht code which says if no major change has occurred, but this is generally not accepted by flags because it is nigh on impossible to demonstrate that nothing, even unknown weights, have made it onto the vessel. There is a very useful reference document there if you wish to make a note of it, a Cayman Islands guidance note on this very subject. But broadly in the table, if we do a lightweight survey and it's within tolerance, then the existing incline and existing stability booklet remains valid. We can just append the lightweight survey report for future reference. If it's outside the tolerance, then we must incline as soon as possible and produce a new booklet. A delay, obviously for obvious reasons, may be agreed between class and flag, so the next incline is done at the earliest possible moment. Just some common issues to watch out for, and we see all the time in incline conducts and incline appraisals, are these points. So they are insufficient heel measuring devices, and we always ask for at least 2 methods to be used, and one of them to be a pendulum. The use of incorrect calculations, particularly for free surface moments, and then on that basis having too many slack tanks. Insufficient pendulum deflections, so when you've got the pendulum and you're not getting a high enough heel angle during the incline. Any unknown hanging weights or invisible dead weight, particularly with yachts, with things getting stashed away behind panels and in void spaces for future use. Or where you have uninformed crew on board that end up doing water transfers or liquid transfers without fully understanding the principle of what we're trying to do for that incline and keeping everything known on board the vessel. Also for yachts, we see a lot of confusion with reference systems, particularly where there's rakes of keels or multiple baselines, as well as simple things such as mathematical errors in reporting, which we seek to pick up, as well as the timing pressures purely ahead of sailing. The incline can come very, very late, such that we may do an incline on Friday and seek to sail on Monday, and the time pressure then is very, very high. So let's move on now to some of the common questions, some of the hot topics, and the things that really we get asked almost on a daily basis, some of the common themes that I can share with you. So as we talked about time pressures a moment ago, one of the big things we get with a new build vessel is this tight timescale, and how do we get around it? Well, we can let the vessel sail with a preliminary stability booklet if the incline has taken place and the result has been accepted. We can do it for a limited time period, typically around 3 months, just for the grace period of producing the new booklet. And if the results of the estimated lightweight in the preliminary booklet are within tolerance of the incline result, such that the preliminary booklet is close enough to what the real situation is. If it's not, we will then ask for a simple small addendum, a couple of loading conditions with the actual agreed new lightweight. And also if there's no other major issues that were found during the preliminary appraisal that would change the game, if you see what I mean. A very common question we get for yachts is a request for a deeper draft. It's very common for large yachts and any vessel to gain weight and for VCG to rise through the life. And particularly for a yacht, you can reach 2 very hard limits. One is that the draft can't go any deeper, and one is that the VCG is too high. And it's very hard to resolve them both because you want to carry more ballast low down to solve the VCG issue, but you can't because your draft is too deep. And there are also then problems on both sides trying to fix them. It may be due to the fact that the original incline was too early. We talked about that earlier. Or it may be simply that through life, the vessel's been modified, weight's been brought on board. Or indeed, the dead weight items have changed, i.e. the owner now wants larger water toys or different craft on board. So it's very common then to request a deeper draft, but it can only be achieved if the deeper draft can be accepted from both load line and from scantling aspects. Then if that is accepted, and it's possible, we will then get a new stability booklet produced and approved, obviously with the new draft, new limit curves, new lightweight, and new loading conditions. If the deeper draft cannot be obtained, because one of those hard limits are met, let's say the scantling draft can't go any deeper, then what next? Well, the only logical outcome, without making any gross changes to the vessel, like modifications or extensions, is to restrict the dead weight. And that means physically, in departure condition, you can't carry all your fuel or you can't carry all your fresh water. Similarly, if the VCG is too high, then, for example, in arrival, you can't consume all your fresh water or you can't consume all your departure, all your fuel oil. So you may have the 10% and the 98% shrunk such that your range of your vessel then reduces. It's not a popular solution. It would be not surprising to say, but it does happen. Another very common aspect of large yachts is the need or request to modify them. That is through owners want bigger yachts, additions, and it can be a big impact on stability if it changes things like the buoyant hull or any other aspects, openings, etc. Particularly always an incline will be required, and then there will be possible changes to subdivision, to tanks, as well as limit curves changing and everything else, everything needing recalculating. We most commonly see stern extensions, beach club changes, arrangements around it in the stern area, and typically extensions to swim platforms, as you see there. That is good because it improves stability, it can increase the waterplane area, so that is a good thing. But just bear in mind, it does, without any other changes, drive a forward trim, which can cause some operational issues. So just something to bear in mind on that. We also see currently a lot of tank changes. This could be tank changing use, changing fluid type, or simply tank divisions to reduce free surface moments or the like. A very common one we get is water ballast tanks being removed in order to avoid the ballast water management convention. So that could be water ballast tanks then becoming voids, becoming permanent fixed water ballast, so fresh water physically locked off in the tank, or it could be replaced by solid concrete or lead ballast. It is not acceptable, it should be said, to simply rename tanks but continue to use them as a water ballast tank. And by this we mean, and we see, pool dump tanks, deck wash tanks, or technical freshwater tanks that by all intents and purposes are being used as a water ballast tank. That is something we are unable to accept. Double bottoms also then generate a lot of questions. There is no requirement in the large yacht codes as a statutory requirement for a double bottom to be fitted, but it is in the class rules, in the SSC rules. And the absence of a double bottom will drive a requirement for some additional damage cases. And less than 80 meters, those damage cases only are between watertight bulkheads. And then the criteria is generally only no margin line immersion, which is what we call a survivability assessment, i.e. staying afloat. We do have an extensive guidance note available on this subject if you require more information. And the table gives you a nice summary. So above 80 meters, the bottom line, then it's looking towards SOLAS Reg 9, the standard double bottom damage requirements. Between less than 50, it's a case-by-case basis. And between 50 and 80, well, there's some requirements for where to fit the bulkhead, to fit the double bottom, I should say. And then that's where we come across this survivability assessment, if there was one not fitted. There was also a lot of debate around tender garage sills. So this comes about because of a requirement for sill heights to be at least 600 mil above the waterline. If not, then we have a special considerations in place. It's most common, as you see in the photo, for tender garage doors, where they want to get tenders out of the side of the yacht. And we can solve it through a number of solutions, through portable door sills and washboards, or through having 600 mil cumulatively on the connecting internal watertight doors is quite common. For any deficient sill heights, any unusual arrangements will generally require a flooding assessment, and that is done on small angle intact stability criteria, noting that this is a a situation that takes place in protected waters. It is not a seagoing condition, so that we can allow some leniency for that. But please always discuss these types of arrangements at an early design stage with class and flag, because they can cause problems when it's very near delivery and they are not resolved. Very commonly, we see requests to include a tier of superstructure in the stability calculations, and this is acceptable if the superstructure tier is compliant with the load line requirements. If it is not compliant with load line, and it's quite often not, then the opening should be modelled appropriately. So by that I mean sliding doors, openings, vents, and the like, that should be then used as a flooding point in the calculations. We also then see considerations for wide bodies. So by that I mean forward of the foremost bulkheads up to the stem, some additional buoyant volume above the main deck. And on that, just things to think about include positions of windows and lights, margin line location for damage calculations. We generally do not permit the inclusion of bulwarks and side casings unless it's been specifically agreed or watertight integrity is somehow demonstrated, but it's not a normal situation. Swimming pools and jacuzzis, very nice that they are very, very common on yachts, but they come in with a detrimental effect on stability due to their location, generally quite high up, their large free surface effect. They generally need to be drained within 3 minutes. And under LY3, that was fine. If they couldn't be drained, we had to assess the impact on stability. But under the new reg code, the link to the draining time is gone. So all swimming pools, jacuzzis, spas, etc. should be included in the calcs. And if they need to be empty for compliance, well, then that needs to be set out in the stability booklet. And the same principle applies for deck recesses, for drain tanks and the like. We should always be thinking about the free surface moments as well and the impact it can have on stability. Helicopters are very common on large yachts. They can be very detrimental to trim, particularly with the installation of helipads as well as the helicopter itself. And the impact on stability should always be considered. The key point on this subject is that we and flags do not permit the use of touch and go helicopters. So by that, I mean the principle that the helicopter never lands on the yacht, it just touches and takes off again. Well, we don't permit that. We always would like to see a loading condition where the helicopter is fully landed and part of the dead weight of the vessel. With short range and private yachts, it's an area of the yachts where if they're not operating as commercial vessels, they can be private, or if they do not wish to seek full damage stability compliance, they can become short range. For short range yachts, the intact stability requirements are slightly different and the damage stability requirements then disappear. But short range yachts, as their name suggests, are limited to 60 miles from safe haven, restricted in Beaufort conditions, depending on motor or sailing yachts. And there's also some tonnage limitations as well, based on the keel laying date. For private vessels, it is common for them to flip private to commercial through their life. So some private vessels seek voluntary commercial compliance, i.e. seek voluntary damage stability compliance, because they may change to commercial in future, or it increases their resale value or their options for the owner in the future. But private vessels are still classed. So they may not require stability by a flag, but LR still requires a stability compliance, and that comes about through a stability booklet. So for that, it's quite the same. Some other issues that don't really warrant their own slide, but are worth mentioning that cause us a few questions are older vessels, such as the one in the photo. They cause issues with unknown hull data, some difficulty in placing their hands on drawings or original drawings or very old or scanned. Vessels that need static party loading conditions. So this is being alongside but having more than 12 guests on board for a party. Multi-hulls and the difficulties that are caused with that, with doing inclines. sail training vessels, which have their very own unique set of loading conditions and requirements. Any vessels that are seeking to be explorer yachts with icing and polar operation, as well as the requirement for some yachts, they wish to have a computer loading instrument on board. So, given all this, just a brief look about how LR can help you. LR is regularly engaging with yards, designers, consultants, as well as flags, the wider IMO, and all of our surveyor colleagues around the world. So we're talking about this on a daily basis. And we're answering questions, design studies, preliminary assessments. Can we do this? Can we do this, for example, as well as final approvals. And on top of the approval work and the technical desk-based naval architecture, we can also assist any client with consultancy services. So that's preparing stability booklets as a consultant, as well as approving them with a suitable firewall between each other. We can do inclines. We can do stability impact studies. We can offer emergency response services for yachts. So that's a 24/7 call-out service, as well as we can also offer advice, provision, and approval of loading instruments for yachts. And if you have interest in any of these subjects, then I can provide contact details on request. So, in summary, large yachts, anything over 24 meters being used for commercial sport or pleasure. The stability approval delegation is on behalf of FLAG, and the stability information booklets demonstrate on board for the master the intact and damaged stability aspects. The incline and lightweight survey, absolutely crucial for a yacht, as well as for any vessel. And then we've also covered some of the common questions, some of the hot topics, and how LR can help you. So thank you very much indeed for listening. My name has been Andy King, a naval architect for Lloyd's. If you have any questions, they are my contact details. And otherwise, I shall hand back to Lizzie.
Thank you, Andy, for a very interesting lecture. As we said before, now we have a time for a general Q&A session, and you can either type questions into the Q&A chat or you can raise your hand. We have a limited amount of time for questions tonight, but we'll try and get through them all. I should bear in mind, if any of you have questions relating to specific plan approval jobs that are ongoing with Lloyd's Register, Andy can't really answer those questions. You should contact him separately about that, basically. So in terms of questions, we have one, which is what kind of software do you use, and what sort of modeling tolerances are acceptable?
So most of the time, Lloyd's use Napa software for intact damage calculations. So we will typically receive the CAD geometry from the client or the yard. We will then use that. We typically use Rhino as an interface to then generate our model in Napa. And then we use IAX URL 5 for our modeling tolerances. So that is given the data, building our own model, and then seeking to validate that model of ours against the tabulated data in the stability booklet, hydrostatics, cross curves, tank data, all the rest of it. That's what we compare it against in order to be sure that we have a model that matches close enough to the one held by the yard or the consultant.
Thank you. The next question is, could you please clarify the meaning of pinhole damage in the context of damage stability?
Yeah, so by pinhole damages, I mean, if you could physically prick each compartment or each tank with a pin, not on any bulkheads, such that you would only damage one watertight compartment or tank. So the classic damage analysis, considering a damage extent with a longitudinal extent, transverse extent, and a vertical extent, does not apply here. We are just doing it compartment by compartment. So it's not as onerous. You don't see situations where you get asymmetric damages. You're only looking at single compartments or single tanks.
Thank you. The next question is, are there typical shortcomings in stability booklet submissions?
Yeah, very much so. Yeah, they typical shortcomings would be incomplete information or information that is inconsistent across a set of documents. So I did one last week, in fact, where things like frame references, datums particularly, tank data wasn't consistent across the PDF drawings I had and the PDF booklet. Other inconsistencies are where it's generally where things have been updated through the build cycle, such that you're looking at data that is either out of date or doesn't quite match what the surveyor is seeing. And I suppose the other big anomaly we get, I suppose, is where we are just being submitted a software printout, which is fine for compliance, you might say, but without topping and tailing it with either the tables of data we need to validate a model, as well as the opening sections, the guidance, the substance of the document, which tells a master how to operate that particular vessel. Hopefully I've answered that question.
You have quite comprehensively answered that question.
Yeah.
The next question is, you mentioned static party loading conditions. Does this mean that a yacht designed for 12 passengers can have more than 12 passengers in those situations? And if so, what are the requirements?
Yeah, it's something that's worth pointing out is that the loading conditions we talk about, the 12 passengers we talk about, is in seagoing loading conditions. Now, it won't be a surprise to anyone who watches the F1 coverage when a yacht is moored up alongside in Monaco that there is more than 12 passengers on that kind of yacht. And also at that situation, it is not a seagoing condition. So we quite often see a request for these party conditions. We can have X number of people on board, and because we're moored alongside, there's obviously a recognition that it is not a seagoing condition. And then we would look to seek to approve that condition for a set of small angle intact stability criteria, i.e. in that condition, does she have a positive GM and does she have a positive righting lever curve for 30 degrees, that kind of small angle requirement.
Thank you. The next question, well, first the next question thanks you for the presentation, and then goes on, do you have to prove you can pull dump in sub 3 minutes if you include the pool full and include its free surface moment in every loading condition tested and shown? No.
So if the vessel can bear the filling of all swimming pools and jacuzzis with a free surface moment, all the rest of it, that's great. And therefore, the pool drainage time is not linked to that. I just hesitate because I would not be sure in saying that the 3 minute draining time then goes away. I am not sure about that. I would have to check that and come back to you.
Okay, I'll let you know who that person was offline.
Thank you. Yeah. I should also say as well, just on swimming pools, another point we get all the time, I mentioned pool dump tanks. We quite often see situations where that can't possibly exist, i.e. you've got a full swimming pool and you've got a full pool dump tank, i.e. that would never happen because you can never dump your swimming pool into it. And effectively the pool dump tank is being used as a aft ballast tank to try and maintain some trim. So there's always some workarounds with pool dump tanks you just have to be aware of. That the filling of that and the swimming pool should always be logical.
Okay, thank you. The next question is, do load line freeboard calculations still have relevance now that there are well-defined stability criteria and assessments? Can we get rid of load line?
That might be a question to be addressed to the IMO in a much bigger question, but my initial response would be no. It's because we're talking about load line just for a draft aspect, but obviously load line covers all sorts of other aspects, conditions of assignment for the yacht. So bit of a big question to say yes or no to.
Yes, and you've also got all sorts of other things like protection of windows and openings and things that all the damage stability is based on anyway. Yeah,
it's a very narrow view of load line for me to impart that we're only thinking about it from a draft assignment. Yeah, and I should say, really, I've talked about stability only. Obviously, there is all sorts of colleagues within Lloyd's, like myself, dealing with all sorts of other aspects that would have other considerations to think about as well.
Okay, the next question is regarding the arrival loading condition. Does LR approve the asymmetrical filling of port side and starboard side consumable tanks for list compensation?
Yeah, sorry, actually, yes. I think that question is more driven around when we say 10% arrival condition, it doesn't have to be 10% in every tank. It can be 10% across the board. So on that basis, if it comes to it and you need to have 2 tanks asymmetrically filled for heel correction, then that is fine.
Thank you. The next question is technology improving in incline experiments? For example, what instruments are being used for the heel measurements nowadays?
So we typically see one pendulum always as a safeguard backup because it is within reason foolproof, accompanied by one calibrated inclinometer. And jointly they give if they obviously set up well and all, everything else being equal, giving very, very good agreement and a very, very consistent incline. The only thing I would stress to anyone conducting inclines, and we can give advice as required, is to always plot and check as you go to avoid the situation we sometimes see of incline reports being submitted and sometimes being rejected if the results are no good, that hopefully could have been picked up on the day.
Thank you. The next question is quite often on stability book DADs, LR requests that the pool needs to drain in 3 minutes, even when we've already considered the pool full and with a free surface moment in all loaded conditions. Can you elaborate on why this may be? I think this works back to the previous question.
Yeah, I'd have to check on that, because since Red Code Part A, the pool requirement has been separated from the drainage requirement. I would have to just come back to you on that, if I may. It's not something I would be familiar with, and why that would be written in the DAD if the pools have all been suitably included and the vessel can bear it in terms of stability compliance.
I'll make a note of that person's name as well for you, Andy.
Yeah, thank you.
Okay, the next question is, if the anchor and chain were lost, would a reassessment of the stability be required by LR stroke flag before sailing for repair port?
Ooh. Again, I'm only speaking on stability aspects. You would think of it as a change in lightweight. So would it impact either 1% LCG or 2% lightweight? I couldn't comment without checking with my colleagues about what that would do for a vessel sailing without that kit from any navigation or collision or safety issues. It's not my area of expertise. I'll have to, again, check with that.
And off the top of my head, it would very much depend on where the port was, and the voyage and all sorts of other things going on there.
If you're talking about, I do have some experience of, doing special voyages for repair and that. Obviously, by all means, engage and speak to Lloyd's, because things can always be discussed, agreed, exempted, or a memo agreed for a certain period of time for a certain voyage to allow those kind of things to happen.
Okay, the next question is, one interesting point is that the max GZ value for wide catamaran can occur at a very low heel angle. How rigid are society stroke flag in accepting cats with lower max GZ angles than quoted?
There is multi-hull criteria in the large yacht code. In terms of how flexible we are, we often see, we talked about exemptions, equivalencies, etc. One such common question is, if you just fail the criteria, and I'm saying you're like just shy of it, can that be accepted? And again, that's always on we are more than happy to have that conversation, to look at the numbers, to look at the wider limit curve, all the rest of it, even calculation tolerances, all the rest of it. It's very hard to give a definite answer other than on a case-by-case basis.
Okay, thank you. The next question is, can you give some indication of how many large yachts that are in service and how many are red ensign flagged and classed by Lloyd's?
Off the top of my head, I couldn't do that. It's that data will exist somewhere, but is not at my hand, not at my fingertips, I'm afraid.
Thank you. And then the next question, and currently the last question, is how do LR include appendages in the stability model? I'm asking because the request is to send IGES without appendages.
Yeah, so generally, unless it causes a huge difference in stability compliance or in floating position, so that's what I'm thinking with trim, with appendages aft, etc. We generally, for simplicity, for complexity, for investment of our time and speed, etc., we don't model the appendages. That said, it's not a case where we would never do it. If it causes a particular difference, we just, on most cases, we don't need it, and we find we get very, very good agreement with models without needing to model the appendages, and we generally get very, very good agreement again without needing to model them. So it's just something that it's a route, an avenue we don't normally go down. The exemption obviously is for very, very large appendages. I'm thinking for sailing yachts and the rest of it, but that's obviously a particular case. I'm talking more about fins, rudders, shafts, and all the rest of it.
Thank you. I think that is it for questions. So thank you once again, Andy, for an interesting lecture.
Thank you. Thank you.
As I said before, this lecture has been recorded and will be available on YouTube probably next week. It takes a little bit of time to edit things and upload them. And the link for that YouTube video will be included in the email that you should receive for the next lecture. And the next lecture will take place on the 9th of December and will be on Tier 3 NOx certification. So we're going to move from yachts to engines. So all topics covered by us. So so thank you all for your time and for your attendance. Oh wait, nope, someone's just sent a new message. Oh no, it's a thank you to us both.
Oh yeah, thank you very much, everyone. Yeah, thank you everyone for joining.
Yes,
it's much appreciated, and yeah, no doubt. Any questions, please get in touch.
Yes, Andy has given you his email address. I hope some of you might have wrote it down, but if not, it's andrew.king@lr.org. If you have any further questions, Andy has agreed to answer them. You can also contact me at techsec@southernjointbranch.co.uk with any questions or anything regarding our lecture programme, or if you want to be put in contact with any of our speakers, we can arrange for that. So without further ado, I'll wish you all a good night, and hope to see you again in December. Well, see you, but hope that you'll all attend the next lecture. And yeah, good night and have a good week, and good health to you all. And yeah, hope things are all.
Thank you, Lizzie. Thanks, everyone.
Thank you, Andy, again.